So we're going to talk about the powers of I. Now, we learned in a previous lesson that I is equal to the square root of -1. So if we have I to the first power, that is the same thing as just simply I. If we have I to the second power, I squared, that's the same thing as the square root of -1 times the square root of -1. Or in other words, the square root of -1 squared. And we'll remember that a squared and a square root undo each other, so this is really just -1. I squared is -1. If we have I cubed, it becomes I squared times I. Well, we know that I squared is -1. -1 times I is simply -I. If we have I to the fourth power, then we have I squared times I squared, which is -1 times -1, which is +1. So these are the four identities that we're really going to focus on. We have I to the first power is I to the second power is -1, I to the third power is -I, and I to the fourth power is 1. So again, those are the four that we're going to focus on. But just for practice sake, we're going to do a couple other powers because you'll see them in your problem set. We're going to do a couple other powers that are larger than this. So let's just move on straight to 5. I to the fifth power. Well, I to the fifth power is the same thing as I to the fourth power, which we know is 1, times I. So 1 times I is just I. So you see the pattern begins to repeat. We have I, -1, -I, 1, I. When we do I to the sixth power, that's the same thing as I to the fourth power times I squared. I to the fourth power is 1. I squared is -1. 1 times -1 is -1 again. So again, we have the pattern I, -1, -I, 1, I, -1. What do you think the next one's going to be? If you're looking at this pattern, I, -1, -I, 1, I, -1. If we go I to the seventh, that's the same thing as I to the fourth times I cubed, which really is just 1 times -I, because I cubed is -I. So this is -I. Is that what you thought it would be when you thought about what would come next? I, -1, -I, 1. I, -1, -I. What's the next one? If I go I to the eighth, what do you think it's going to be? Well, it's I to the fourth times I to the fourth, which is 1 times 1. So I to the eighth is 1. So again, if I go back and I'm looking through this pattern, I see that I have I, -1, -I, 1, I, -1, -I, 1. So there's a pattern here, and it just repeats. Every four numbers it repeats. So I've got I, -1, -I, 1, I, -1, -I, 1. Then it'll repeat. So I to the ninth, I to the ninth, without even breaking it down, I know that I to the ninth is going to be I. And I to the 10th is going to be -1. And I to the 11th is going to be -I. And I to the 12th is going to be 1. But what if I go crazy and I say, what about I to the 34th? Well, all I have to do is take this exponent, divide it by 4, and look at the remainder. So here I go, and I say, all right, just to do some side work here, let's just come over here and do some side work. 34 divided by 4, well, it goes in there 8 times, and that's 32. So there's a remainder of 2. Well, what is I squared? Let's go back up and look at our notes. What is I squared? It's -1. I have a remainder of 2. Then I to the 34th is going to equal -1. And I can do that with any number. So even if I take a really large number, like 324, I can divide that by 4 still. So 4 divided by 324, it goes in there 8 times. It goes in there 1 time. So this is 32, which is a perfect 0. It goes into 4 1 time, which is 0. There's no remainder, which means that this is a multiple of 4. I to the 4th is 1. Let's do another example. And if we were in class, I'd let you give me numbers, but let's just make some up. 629. How about that one? 629 divided by 4. Well, 4 goes into 6 1 time. Then we have 22, right, because we brought this down. 22, it goes into 22 5 times, and that's 20. And now we have 29, it goes into 29 7 times, which is 28. And we have a remainder of 1. Well, I to the 1 power is I. So I to the 629 is I. Let's do several more examples, and I'll just kind of use the other section of the page over here. I to the 521. I to the 521, so we'll go 521 divided by 4. Goes in there once. There's 1 left. 12 goes in there 3 times. That is 12. Sorry, I'll write that 3 a little bit better. That's a 3. Nothing there. 4 does not go into 1. So we have a 0 times, and we have a remainder of 1. I to the 1 power is I. So I to the 521 is just I. On the problem set, that's what we'll do. We'll give you one of these numbers, I to some power. You'll divide it by 4 and figure out what the remainder is. And once you have the remainder, then you'll use one of these 4 options. If your remainder is 1, you'll type in I. If your remainder is 2, you'll type in -1. If your remainder is 3, you'll type in -I. And if your remainder is 0, or in other words 4, because it's a multiple of 4 if it turns out to be 0. If your remainder is 0, then you'll type in 1. So again, a couple more examples down here. I to the 23rd. I to the 23rd, well, if we divide 23 by 4, we know that it goes in there, 4 goes into there 5 times, which is 20. Our remainder is 3. If our remainder is 3, it's the same thing as I cubed, and I cubed is the same thing as -I. I to the 15th. Well, 4 divided by 15, we know that 4 goes into there 3 times, which is 12. We have a remainder of 3. I cubed is -I. How about I to the 17th? Well, 4 divided by 17, sorry, that looks like a square root sign, divided by 17, goes in there 4 times, which is 16. There's 1 left, which is I. What if I did I to the 18th? Well, I to the 18th is going to be 4 divided by 18. Goes in there 4 times. That's 16. There's a remainder of 2. So that's going to be equal to -1. And again, that's the process you'll go through on the problem set. You'll see a bunch of these. You'll divide them by 4. You'll take the remainder and decide which of these 4 green rules you're going to use. Remainder of I. Remainder of 1 is I, remainder of 2 is -1, remainder of 3 is -I, and remainder of 4 or remainder of 0, right? So I'll just put this in blue over here really quick. I to the 0 power, that's the same thing as 1 because anything to the 0 power is 1. We learned that in exponent rules. So I to the 4th is 1. If there's a 0 remainder, it is 1. Good luck on the problem set.